Hello, hello, hello.
Hello, hello. Good
I,
afternoon.
it is. It is nicely just afternoon. I'm only a few minutes late.
Yeah.
Thank you for joining me today, Arian. How are you?
I'm good. Yeah, I'm considering the circumstances, but yeah, it's a good day
Yeah,
to be inside because it's raining. So
yeah. Where are you based right now?
I'm currently in Berlin. Yeah,
Ah,
so I work here at Wire for the past year now. I moved to Berlin, and then I ended up working from home in Berlin because the office is closed, obviously. So this was not completely as planned, but it's still fun. And yeah, and I will probably plug that we're hiring people for Kubernetes things if you're interested in that at the end of the show. But that's not always looking for more people. But yeah, I do DevOps stuff there. So I do both development and operations, responsible for keeping all our infrastructure running and building new features. So we're kind of a mixed team. We do all kinds of stuff. And in my spare time, I also torture myself with these kind of things. And yeah, actually, I didn't have IPv6 at home in Netherlands because we only have like 15% adoption rate, like one of the lowest in the world. And Germany, it's like 70%. It's super high. And so when I moved here, I noticed I had an IPv6 address. Not only one, I had a trillion per machine on everything on my network. I was like, this is very weird. And how does this work? And then I decided to learn a bit about it by messing around with it in Kubernetes. And that was a bit of an adventure. So
well, I'm hoping that we can take all of your learnings from that adventure, and
yeah,
well, I can absorb some of them, and we can share some of them with the people that are watching as well.
yeah,
It's going to be awesome.
yeah. So
You're
that's a bit of
also
the
quite involved in Nix, right? You're my go-to Nix person. So.
yeah. So I do maintenance for NixOS. I maintain the system D packages, and that also touches all the container stuff automatically. So I'm kind of in that area, making sure that service management works in NixOS and having all that stuff running. And I also do the Let's Encrypt stuff for Nix. So automatic certificate renewal for if you create an nginx service with NixOS and stuff. Yeah, that's a lot of fun. Yeah, it is. Yeah. Also, if you want to check out this project later, it's also set up with Nix. It will download the right version of Kubernetes and everything. It's yeah.
Awesome.
Yeah.
So, my screen. So I guess my first question then, we'll dive straight into the why. Why are we doing a Kubernetes IPv6 only cluster?
Yeah. So what did you think the first time you learned about like Kubernetes networking? Was it very obvious to you, or were you very confused? Because I was very confused the first time I read about all these things, like overlay networks, pod networks, service IPs, NAT, kube proxy. It's like
Oh yeah, it's very
it's
confusing. There's so much to
yeah,
take in, so many
yeah,
different components, and then depending on the CNI implementation, there's
yeah.
different abstractions on top of that. So.
Yeah. So you have to choose, like, the first thing is like Kubernetes is going to make everything super easy once you make all these difficult choices, right? Like there's 20 different CNI plugins with your VXLAN, IP overlay networks, or you can use the stuff from your cloud provider to set up routing, and there's like a million different choices, right? And so one of the first promises that Kubernetes makes is like your pod network is flat. Every pod needs to be able to talk to every pod without any netting or whatever. Every pod gets an IP, and it needs to be reachable for each other, right? And kind of the thing with that is that it means you need to have a unique IP address for each pod that you spawn up. And with IPv4, that's kind of expensive because IPv4 addresses are not cheap. So what we usually have is we assign pods private addresses, and then we set up this overlay network using, I don't know, some IP and IP overlay network or something, such that all the pods can talk to each other. And the only reason why we have this overlay abstraction is really because we cannot give each pod a public IP address and let just routing magic happen, right? And then IPv6 was designed, I don't know, 25 years ago, and they said, well, what if we just make this address space bigger, and then we can just give every device a public IP address, and then we don't need to bother with netting and overlay networks and all this stuff. And every device gets a public IP address, and we just set up routing tables such that things route the correct way. And this makes the world a lot easier in my head, because I don't have to think about what is the IP address of my router it's just when I go to a website, they see the public IP of my laptop. It's a one-way route, right? And this also makes it fits very well this pod networking model. Like every pod has an IP, and each pod can reach every other pod. Like it fits this IPv6 world perfectly. And we do not need to, well, we can still do overlay networks and all this stuff, but we don't have to. If we just assign everything a public IP and we make sure that there's routes between the two node or 3 worker nodes, they know that they can route pod IPs from one to the other, then we can just expose all pods directly to the internet. And then people will say, well, that's not secure. What are you doing? Yeah, we'll get to that later. So I think for that, IPv6 is really cool because it really fits this network model of we have a flat network very well. And that's like the basis of Kubernetes networking is we have this flat network model. And if we pick it, then we have a lot less stuff to worry about. So I think that's a bit of a reason why I think IPv6 and Kubernetes is useful. Also, yeah, you get a lot of IP addresses, so you don't have to worry about all this IP address management and how many pods can I schedule, and I don't know, they're infinite. You don't care. It's just if you want to schedule 1 trillion pods, it will still work. But so yeah, just having a flat address space makes things a lot easier. And
exactly.
Yeah.
So there were a couple of things there. First, hi Adrian, thanks for watching. Second, I just googled it as you were chatting there about IPv6 being 25 years old, and I was like, oh, I remember I read a story about we ran out of IPv4 addresses. Yeah. And that actually happened the first time in 2015. I believe North America ran out of addresses. And then officially all IPv4 exhaustion happened in 2018. So it's been over 2 years. Yeah. And we still haven't got this sorted yet, right?
Yeah, correct.
But today we're going to do it. We're going to have a IPv6 Kubernetes cluster.
Exactly.
So is the security, like, I mean, the first thing when you say, let's give every node an IPv6 address, like you mentioned the security thing. Is that something you want to talk about now, or would we do that as we begin to spin this up?
I left it as an exercise for the reader, of course. No, but we'll talk about it at the end. But I think we have a good story for it. So basically, if everything is public, you're forced to make proper firewall rules. That's basically the trick. Instead of relying on the fact that your overlay network is not reachable from the internet, this is all about security through obscurity, right? It's not that you... And Kubernetes has some very nice things for this. So you have network policies where you can describe declaratively what pods can talk to what pods. And if your CNI provider supports it, it will make your network secure. And you can also do things like, I don't know, service meshes like ITSO to have everything encrypted. And this is all levels that you put on top. We'll start with every pod can reach every pod. As a side effect, it will mean the whole world can reach every pod because it's IPv6 and everything is public. But if we start from the basis is very simple, then we can bolt on security later. And yes, it is important, but it is also important if your pods have private IP addresses. Because, I don't know, maybe for some reason you have some rule in your firewall that forwards things to your pod IP space, and then still things from the outside could reach it. So it's always good to have this kind of network policy set up inside your Kubernetes cluster. And making everything public by default, we're kind of forced to do this zero trust thing, right? Where we trust nobody and we have to bolt everything together. But I'm not sure if we're going to get to that part, but I can give some links on how you could set that up. But we're just going to go for a very insecure, very public Kubernetes cluster today, I think.
Okay.
Yeah.
So, I mean, I've got thousands of questions, but rather than talking about it abstractly, I think we get started, we put it together, and then hopefully the moving components allow people to kind of follow along as well. And there's just a little bit of noise in your mic. If you could just push it away a little bit.
Better? Yeah, sometimes it picks up the breathing if it gets too close. Yeah. Just tell me when it happens again, because it tends to slowly move back.
That's all right. Perfect. Okay, so I am going to share my screen. I have, at your request, created a server. The reason we have a working node server is because this cluster is only available in IPv6 space, and my ISP does not allocate me an IPv6 address, crucial virgin. So this server is here so that we can interact with that cluster when we spin it up. It's the only reason I will be working remotely today. I have a VS Code window here, which if I create a hello.txt, your cursor should magically show up. So we have the ability to collaborate on this as we go, which means that you get to fix all of my errors, which is awesome. And we have a terminal where I have configured just enough and hopefully not forgotten anything to get us through this. So I have provided Terraform. I have installed Terraform, kubectl, and Pulumi.
Yep. We will need one more thing that we need to install. We're going to need to, kubeadm we don't need. We need that on the nodes. That's going to be fine. We'll need Calico CTL as well, because we're going to use the Calico network plugin in this demo. And it uses its own command line tool to configure things. So it uses custom resource Kubernetes custom resource definitions, but not for everything. So for some things, you still need their CLI. So yeah.
No problem. So we curl that, chmod plus x. Give that a second. There we go. And we can move this.
Yeah.
Okay, so we have everything we need, and if we need anything else, we'll deal with it as we go.
Yeah.
All right. Step one. What do I need to do?
So we will need some servers, right? So I will need a master node and some worker nodes, so we can set those up.
Okay.
And I've never used Pulumi before, so I'm very curious.
Well, I'll talk about why I like it. This directory isn't empty, so actually what I need to add is force. I'm using the packet TypeScript template, which just means that it configures the provider to provision packet infrastructure, and I'm going to choose to write my code in TypeScript. One of the things I really love about Pulumi is that you can use most supported programming languages, so you can use the tools you're comfortable with. For me, I use TypeScript. You may wish to use Go or Python, and even .NET is supported. So it's cool. Now this wizard is going to ask me for the project name, a description, and a stack name. Let's call it prod. And something I really like about Pulumi as well is it has a configurable secrets provider. By default, I can just type in a really secure password, and hopefully I remember what I'm failing at typing today. Okay. Don't know if that's even right. Okay, so by default, we're using a password-based encryption, which means any secrets I add to this project will live in the Git repository encrypted with that password. It does also connect to cloud service KMSs and to Vault. So if I really wanted to make this a bit more secure, I could say, go speak to this Vault server, get a management key, or go speak to GCP, KMS, AWS KMS, or even Azure KMS. So,
yeah, that's nice.
Yeah, Pulumi is cool. Although I know it's one of these really superficial things. It does bother me that the index.ts gets created in the root directory. I don't like that, but I'm not going to let that.
Not going to let that stop us, right? Yeah.
No, I'm going to pick it. So I'm just going to create a source folder, and I'm going to go in here. And the only thing I need to change is main source index. Okay. Cancel. Okay, so we're now in a position where we can create a server.
Yeah.
Okay, so this should have installed the SDK for me, which means I should already get autocomplete. So I'm going to confirm that first. Is this like a management server I need to create first? Do we need more than one server?
We'll need a master node and a worker node, so let's have 2 in total. We can have 1 and do everything on there, but it's more interesting if we have 2, because then we can demonstrate that networking across nodes actually works, and I'm not bluffing. So let's do 2. Yeah. We can maybe let's do. So you want to make one like where the control plane is going to run, like the kube control plane, and then some workers.
Okay, got it. So let's do our admin server, which I'm just going to call admin. And this is a few required properties. So facilities, we'll go over it, answer that. We will need multiple. Okay. Are you typing? Are you just trying to trip me up? Is that what it is?
No, I'm not touching the keyboard at all. No.
And we get autocomplete on the operating system, which is
Yep.
awesome. So let's go with Ubuntu 18.04.
There
are newer versions, but I think the provider doesn't have all the list yet.
So. Yep.
Okay, so we do need a project ID. Let's put that as a question mark. We'll need to bring that to configuration.
Yep.
And we need a plan. And is there any minimum sizes that I'm going to require here?
So I've been using the old T1 micros, which I don't know if they're even. I can still spawn them up, but they are not in the list anymore by default. So just the smallest thing, it's fine. There's no.
Okay, I'm going to go with C2 medium.
Yep.
And what else does this require? So it's telling me I need a balance cycle, and my facility shouldn't be 3, I think.
Oh, I lost connection. Wait, reconnect. Let's see.
Hopefully they're okay. Okay, so let's do balance cycle. Let's do monthly. I think that should be array. I'm not sure why that's. What am I missing now? So argument type facility. Host name is missing. Okay.
Yeah, we need a host name. Yes.
It's just admin.
Admin. Yeah.
The red squiggles are gone. That's a good thing. Cool. So the project ID is currently lacking. Plus, we also need to tell this. We need to configure the organization. So we've got 2 setup pieces that we have to do. So first, Pulumi config set. Let's do project ID. And I can grab this value, which is not a secret.
So you pre-created a packet project, right? It's
correct.
Yep.
I don't believe I need the organization ID, but I will add it just in case. And we need 1 secret is our off, and that just gets namespaced as packet.
And it will get it from your secrets file automatically, or how does this work?
I'm going to paste it in while no one is looking. So if I just hit return here, pop over here, and find my file. I'm still getting used to this Mac nonsense. Okay, there is my API token. Oh, if I have open, it's going to open it and close it. And cleverer than you. Okay. And then because this is a secret, we provide a password, it encrypts it. And if we don't need to see view, if we open our production configuration, here's what we have. So we have two project-specific configuration options, project ID and organization ID. And we have a packet provider configuration with our auth token, which is nicely encrypted with my super secret password.
Perfect.
I hope. So, do I need to provide organization? It does not appear like I do. So the project ID is enough with my API token. I think we're almost in a position to test this. So first, we need to get our config. New, and then replace our project ID here. This is going to be require, and we called it project ID. Then the moment of truth.
Let's see. And now you forgot the passphrase, right?
I have not forgotten the passphrase.
There we go. Good.
All right. So we haven't really allocated any user data here. I'm assuming we actually want this machine to do something, right?
Yep.
No?
But, well, so do you want to do all this stuff through a user data file, or do we just want to SSH into it and go through the process manually? I think that it's better to do it manually because we'll probably make some mistakes. And if we have to wait every time to re-provision a machine, if we change the user data, it might be a bit slow. So we can act as if we're doing this all the correct way, but we'll just SSH into the box and do stuff there, I think.
Okay, so as we SSH and do stuff, I will just update something locally in a repository, and then when I publish this online, it will be fine.
Yep. Yeah.
So it's saying that my balance cycle must be one of error there. Which I changed it to error name.
Yeah, I actually do also have a reference repository I can share afterwards, which sets this up on the Flatcar Linux with some user data. So if people want to run a demo from scratch at home, then it should work.
Okay, I will try this one more time and assume it was just syncing my changes remotely because we are using a remote dev container. Now that that's error, hopefully it works. That looks much better. Okay, so we have a machine spinning up.
Yeah.
So we have not tweaked the networking configuration of this machine. So that means that by default, we are going to get a machine that has 2 IPv4 addresses and 2 IPv6 addresses, I believe.
One IPv6 address, actually.
One.
Yeah. Yeah. Because so we will get a private IPv4 and a public IPv4. And we'll only get one IPv6 because there is no such thing as, well, there is such a thing as private IPv6, but it's highly unusual to use. So, one thing that you'll also see in the Packet project is that not only did we get an IPv6 address for the box, in the project itself, under networks, under IPs, we'll see that we now have a public IPv6 block allocated to our project. And this has trillions of IP addresses. So it's 2 to the power 72 IP addresses that we got assigned. And we will use this later because we'll use this block also to allocate IP addresses for our pods. So not only for the nodes that we create on Packet, which Packet will do automatically, we'll also do it for the pods. So can we have data sources in Pulumi? Because I want to get this IPv6 block into our config because we're going to need it. This is something we can do.
Yes, we can do that. We have access to yeah, we can use data sources the same way Terraform uses data sources. Definitely.
Yep. So we can either copy paste this block, or we can use a data source to retrieve it, and then whatever you think is cooler.
Okay. Let's store it as a config right now. We'll see how we're doing for time, and I can always, clean this up later. We'll focus on the Kubernetes IPv6 stuff.
Yeah, exactly.
So let's just split this term and Pulumi config set IPv6 block.
Exactly.
Okay. So that's just going to take Ubuntu 18.04 is one of the fast provision boxes. I would expect this to take maybe around 2 minutes, maybe 3 worst case. We look at the progress, we can actually see it's just rebooted and it's going to phone home. So it's actually almost done.
Yeah, cool. Okay.
The other thing I did do was enable BGP on this project. So we do have BGP set up.
Yeah. So there's also, just for the record, we're going to use Calico, which is a CNI provider that integrates with BGP. And for the listener, BGP is a protocol you can use to talk to your router in your data center to announce routes. And what we will do is, and we'll also see this update in this window later, is we'll announce where pods are in our data center. So we can tell the routers at Packet, this pod is running on that node. So if you get a request to this pod, send it to this node in the cluster. And this way, all the pods can find each other. The pod will send the requests out to another pod. It will go through the Packet router and then to the node that has it. And we'll use BGP for that. One thing that we'll have to set up also is we will have to tell Packet that this server that we created is going to talk to the router. And in Terraform, this resource is called, let me peek, Packet BGP session. So we'll have to create a Packet BGP session which associates the device with the Packet router.
Okay, so BGP session, so new Packet BGP session.
Exactly.
And this is our admin, is this just our publisher for publishing routes? Is that right? Okay. So what do we need here?
I think a address family and a device ID are the two things that we'll need. So this will be IPv6, and then the device ID is the server admin. Yeah.
ID.
Exactly.
Do we also
do we already want to create a worker device as well? We can just copy paste this code and set hostname to worker.
So server worker worker one. Is that it?
Yeah, and then also create a BGP session for it because we'll also need it.
Okay, so do we one of I don't always spend too much time on the Pulumi stuff, but because we need to do this repeatedly, what we can do is if we grab this, we make this a function. Which returns a new server. And then here we say create server. And we'll inject our main with string thing. Oh, sorry, what's that? Multiple string types. A host name, which I guess we can just make the name of the server.
That makes sense.
That's it, right?
Yeah.
So here I want to be able to reuse that resource, I'm just going to call that admin and not change anything. We will then, I never remember how multiple processes work on a Mac. Anyway, server, worker 1, server, worker 2. And are the BGP sessions the same for all of these?
Yeah, so there will always be address family IPv6 and then the device ID. Yeah, and this is just so that the packet routers know that these servers might announce routes to the router. Otherwise, it will reject all the BGP traffic. So.
We will have this return a JavaScript object, which now has a BGP session.
Yeah, we'll give it a name and then.
It's like I can't do an internal reference.
Put that in a variable. Yes.
If I was smart, I would have called it device.
Oh yeah, then can we use this fancy JavaScript syntax?
Yeah, there we go. We're refactoring our code. So now we have a function that creates a server and a BGP session, and then we create the 3 devices and the 3 BGP sessions.
Yep, sounds good. So let's just apply that, and then we can already start on the admin node and configure some stuff.
Perfect. So if I hit Pulumi up, password. Okay. 5 to create. I'm hoping that's going to realize it's wrong.
Yeah, well, you would expect it to. Well, it's not creating the device, right? That's good.
Yeah, it's only creating the BGP session. Okay, good, perfect. So I get 2 unchanged.
Yeah.
All right, so let's jump on to our admin node.
Yeah.
I never thought of this part. I will do this from iTerm. I don't think my key is going to be passed through, but let's check. Directory, put your font, and SSH, yeah. Now I have access to my YubiKey. We're in.
We're in. Okay, so we're gonna use kubeadm to bootstrap a Kubernetes cluster. Have you used kubeadm before?
Not in 3 or 4 years.
Okay. So it is not too complicated. Usually it's just you type kubeadm in it, and that's all you have to do. But of course, because we're running IPv6, we need to tweak some configurations. So we just need to install kubeadm and the kubelet so that we can bootstrap things.
Oops, I broke it. So then because sims sudo, but we're just running a root. Are there any more sudos?
Yeah, there's still a sudo apt key. Yeah, perfect. Yeah, and this is obviously something we would add to our user data usually, because we'll have to run it on every box. And I'm going to cheat a little bit and give you a kubeadm config instead of us reconstructing it from scratch.
If it's on your repository, I can always browse to it.
Yeah, so it is in my repository, but it's templated. And we'll have to fill in your IP addresses.
I should have just used the Terraform, but we'll keep going.
No, it's fine. I have plenty of time. It's okay. I will send you a link. Shall I share it through the?
Yeah, just use the private chat.
I've put it in a comment in the index.ts.
Fancy.
Okay. So you'll see a kubeadm/config.yaml.
Yep.
Which contains everything we need. So if you just copy paste that into a file, and then we can fill in the blanks.
Okay. So let's just call this original kubeadm.config. So in fact, highlighting it, I think no, it's YAML, obviously.
YAML, yeah. So
something Kubernetes that isn't YAML, or was I thinking?
Yeah. So this is an ignition config, and we only need the kubeadm part of this, so we can remove a whole bunch of things. So this is basically the user data of my flat-core Linux device. So if I will, let's see, I'll just open the window as well, and then I can edit, right?
Mm-hmm.
Okay. It's loading. Come on. It won't load. Live share is cool when it works.
So
okay,
if I just close it and reopen it, you'll get popped into it anyway. So let's do that.
Nope. It seems to be sort of disconnected somehow. It's still convinced that you're editing the index.ts. This is. But yeah, if you scroll all the way down this file, you'll see a little bit up. You'll see this kube. Yeah, down, more down. Yeah, kubeadm/config.yaml, and this is the only content that we need. So, there's the contents of that file is the only thing we need. So we can remove all the other stuff in this file. Just copy that out. Yeah, exactly.
And we just want this available on each of our nodes, right?
Yeah. And so we'll have to edit some things, some placeholders. So the certificate key and bootstrap token you can just remove. We don't need them. When you leave them out, kubeadm will come up with default values, so we can just delete those. Then there is the node IP, which needs to be the IPv6 address of our node.
Okay, so is that our admin node?
Yeah. So if we go into details, we will see the IPv6 address. Yes, that's it. Okay, good. And then we'll have the control plane endpoint, which will also be the IP address of this node. And then we will have to come up with two IP subnets for our service range and our pod subnet. So this is where our virtual IPs will live and in which range our pods will live. We don't want this to clash with nodes that Packet creates automatically. So what we're going to do is just copy paste the IP address you just had into both. Okay, remove the 3 in both cases. Okay, and the service subnet we will make D001. So you see the D000?
Oh, gotcha.
Oh yeah, and then just leave the yes, and then we'll do a /108 at the end. So this basically means that we will allocate all the service IPs will be prefixed with this part, and we need to do /108 because we can only have 1 million service IP addresses in a Kubernetes cluster. It's some hard limit. If you change this number to something that is normal in IPv6, because usually you assign a /64 per range, Kubernetes will actually crash. I found this out the hard way. This is not documented anywhere. 108 is the magic number that we need. And don't ask too many questions. And then the pod subnet will make D000, we'll make it 2, and then /64. Yes. So this means that we expect all our pods to get assigned a public IP address, which is what we want, right? So yeah, we can put this in a config.yaml, which we copy over to the box.
Was it if you disable the commutes formatting?
Oh yeah, set based or something, right?
Yeah, I think you're right.
And then we want to indent this a bit.
Yeah.
Okay. Yeah, let's just do it that way. Yeah, that's good.
Right there. Okay.
Yeah. So let's save this, and now we're gonna type. Okay.
Okay.
So there are a few things that we need to make sure before we can initialize the cluster. First is that we have a DNS server in etc resolve conf that is an IPv6 address. The reason for that is our pods will only have IPv6 addresses, and they won't be able to resolve external traffic if this is an IPv4 address. So we can pick one. If you go back to that file, I think it's in here. Oh no, wait, it's not. Wait. So we can, I don't know, take the Google servers or something. I will.
All right, I'll just go it.
Yeah, exactly. There it is. Yeah. So let's put these in etc resolve and replace those two at the top. We can keep one IPv4 one in there actually, because otherwise other stuff will get angry. So yeah, exactly. Perfect. Okay, so now we can do sudo kubeadm init -- config and then your config file. And it will run a bunch of pre-flight checks that will tell us things that are not configured correctly on our box yet. We might have to set up a forwarding rule in the kernel or something, or Docker isn't started yet. So yes.
No Docker.
So let's apt install docker.io. Let's you suddenly start to appreciate these managed Kubernetes services, right? It's like, yeah.
Yeah, I used to work for a company that runs like a tender competitor in Europe, and we managed all of their Kubernetes clusters in bare metal, and it was fun and challenging at the same time.
So what is it angry about now? Oh yeah, we need to disable. Yeah, we will have to disable swap. So just swap off. Oh yeah, enable Docker is also useful. And then I always forget what you need to type here.
STB2. Okay.
Yeah, perfect. Oh yeah, and we need to set proxys net IPv6 config default forwarding to 1. The reason for this is we're gonna receive requests from other nodes trying to reach a pod IP, right? And our server isn't listening on any pod IPs. It's the pods themselves that are listening on the pod IPs. So if it receives an IP address that it doesn't know, it needs to forward it to one of the pods on the box. So we have to set up IP forwarding for this.
Yeah, I was trying to work out why that exists, but I forgot the key. Okay.
So I think we're now all set, and we can start bootstrapping it.
Okay, let's try that again. Okay.
So yeah, this will take a minute or two whilst it downloads all the required components. Or it will crash halfway through because we forgot something.
Okay, in the static manifest.
Yeah.
Now, so now it's going to be pulling the images for each of those static manifests. Okay.
Yeah. And it will actually print out instructions how we bootstrap our worker nodes. So So don't. I knew you would do that. You always tell me you do this, right? This Control L. So scroll up a bit. There's important information that we need.
There is, but I was wondering whether I really want people to be able to join my cluster.
Yes.
It's okay. We'll just set it
So
down.
yeah. So first of all, we can download the kube config. That's useful, I guess. So that's the very first step. So the kube config for this cluster is in etc kubernetes admin.conf, and we can copy it from the box to your management node if you want to, so that we have kubectl working. We can already see if that works. So if you would do kubectl get node, see if it works, and then yeah, exactly. Let's copy that. So yeah, as you can see, the node is in a not ready state because we haven't installed a CNI plugin yet. So there's no networking setup yet.
Yep.
But we'll get to that very soon. Do you just want to do it from the master node? Because we have IPv6 connectivity here as well, so it's I know it's nice and easy. So we're gonna install Calico. Shall I just send you a link to the commands that you'll have to type?
Yeah, go for it.
Yep. So we will need the following two things. Where are you? It would be nice if we can get the shared terminal up again. Do we want to try and see if we can get the live share to work? Can you?
Yeah.
Do you see me type in index.ts now?
I do.
Yes. Okay. So
you should be able to type in my terminal, which is on the working node. Do you want me to? Is that okay to do the commands there? Or no, we'll need the config, right?
Yeah.
So
we will need the kube config there though, so the kubectl works. That's all. So export kube config equals kube config. I need the full path here, right? I think.
No, you can just do /.
Oh, okay. There we go. That's nice. Okay, so we're now gonna copy. Oh, I accidentally did something. What did I do? I created a new terminal by accident. Still works, okay. Pasting is a bit funky here.
Can't believe you're using kubectl create after my Twitter rant about people using kubectl create.
Instead of apply?
Yeah. A rant for another day.
Yeah. And then we are going to get Calico installed. So Calico has an operator to manage Calico, which is kind of neat. And then I will make a new file here. Oh, Control N opens a new browser tab. Let's see how I will press this. For some reason, it doesn't like me changing files. It just doesn't work in live share. So the terminal works fine. So
so there's a little, sometimes, yeah, I've had that before in live share sessions too. There's a little like reload. I don't know if you can see my screen right now, but if you press that, it generally kind of kicks it. The refresh explorer button.
where is this button?
So on the sidebar above the files and directories, there's like 4 icons, and then there's like a wee circle with an arrow on it, and that generally just kicks it to refresh the file system cache.
No, if I open a file, it just gives me a loading screen. So I'll have to guide you in typing. This is
okay. I can do this. I can do it.
Yes. Okay. So let's go to. I'll give you a link, and then I'll tell you to try it yourself. This is always fun. Let's see what the link is.
So is this on your GitHub still? Can I get it from there?
Yep, definitely.
All right. So top level, I go and say.
Go to ignitionmaster.yaml.
Got it.
And we're going to copy, and I'll scroll all the way to the bottom. And you will see a Calico config. We're going to copy paste that. So I actually just noticed this flex volume path thing. You might have to, so this is only needed on Flatcar Linux, because by default it tries to install flex volume plugins in user libexec, but that doesn't exist on Flatcar. The thing is, we also configured our control plane to use this path, I think, in our kubeadm config. Can you double check that? Because we might have to remove that part. Like that. Yeah, so this, it might be that it starts complaining about this path. So we could quickly try edit. Yeah, so if we go back to your terminal and we edit the config first. Yes, and we remove those extra args. So yeah, both there and also in the cluster configuration. Yeah, exactly. And then you can do kubeadm reset. And then without the config. So first we do reset and then we reinstall again. So we just do reset.
Okay, and then we want to run init again.
Exactly. Okay.
So
and then we want to
put this on the machine, right?
Yeah. And we also want to now do the kubectl create or apply again.
So let's add it first, and then the command. I've seen it in here actually.
Yes, it's in here. Exactly. Yeah.
So we can run this.
Mm-hmm.
My config. Okay.
Yeah, you have to copy the kube config again because we now have new certificates, right? So. Oh, it copies interactively, so it refuses to override it because there's a cp-i.
Of course.
So. Okay, good. And now we look at this Calico file that you have. And it's different from the one they ship by default. So we will have to change one thing here. The interface is I think it's bond 0 in your case as well. Could you make sure that it is? It is, good. So I disable IPv4 detection and I enable IPv6 detection. And this is just so that Calico configures itself as a for IPv6. And this, by default, it does IPv4 with an overlay network a la Flannel. But if you have this option, it will use IPv6 instead.
Okay.
So
So
we
I
can
can just paste in. Oh, I copied that by mistake. So I can paste in kubectl create pointed to my
No.
Calico file. No.
Yes. Yes.
Sure. You said no.
I wanted to say no, but it's yes. Yeah.
Ta-da.
Yeah. So now if we do kubectl let's get all pods, we'll see that it's creating some stuff.
Right.
Yeah, and it will take a little while for the Calico to come up.
Okay. Nice.
And
So what we did there was we installed the Tigera operator, and then based on the calico.yaml file here, it's determined that we need these pods, right?
Yeah, exactly. Yeah.
Okay.
And so the Calico kube controller will listen to network policies that you define and configure firewall rules. And the Calico node is what we call a BGP speaker. So what it will do is it will, after we set it up, we haven't done it yet, it will talk to your router, to your gateway, and it will announce, so Calico node will run on each node in your cluster. And it will say, I have these pods, they have these IPs, and they are on this node. So it will say, pod nginx1 is on my node. So if you see the pod IP of nginx1, you have to route it to me, and I will give you the answer. So once this is all initialized, can you check if it's up yet?
First.
Yeah.
Very good.
Yeah. So, and if you do kubectl get node, it should say ready.
Ta-da.
Okay. So let's create an nginx deployment. Let's just create some pods on this. Well, we'll have to remove the taint from the control plane node. Do we want to spin up a worker first? We can do either. Yeah.
We'll remove the taint, and then we can add the worker.
Yeah.
Okay. And we want to create run nginx.
Yeah, dash image. Yes. Okay.
Okay, so the image is pulling.
And let's see if it gets assigned an IP address. Can you do -o wide? And we can get. Okay. So we see now our pod has a public IP address. However, okay, we should be able to reach it from this node. So if you curl it, it should work. So we have to put it between brackets, the IP address, square brackets. And we should be able to get, yeah, that works. However, if we try to run it from any of the other nodes, which we don't have, well, we have them, or from the outside, we will not have a route to this node because there's no way for other people to know that this pod is running on this node. And this is where, yeah.
Let's jump onto worker one then.
Yeah.
So we have our admin node on the top. Oh, why am I going to add this to the IPv6? YubiKey. Okay, so if we copy this curl command, you're saying this will fail, and that's because we're not advertising this address, right?
Yeah. Oh, you missed the square brackets. So nothing happens, right? There's no route. So now what we're going to do is we're going to teach Calico about how the network infrastructure of Packet looks like. And what Packet looks like is every node, every device that you create will also have a gateway address. You can also see this in your Packet, in the Packet screen. And the gateway is the address of the router you talk to. And this means we'll have to tell this address, hey, these pods exist and they reside on me, and I will be able to resolve this IP address for you. And this we do through BGP. So we'll set up a BGP session between Calico node pod and the packet router, and it will then start telling the packet router, I have these pods, you can contact me for this pod. And so that will be the next part of our party trick, I guess. We can again go into my repository.
Got
and
it.
you will see a file called bgp-peer.yaml.
Yep.
Yes. And it's templated, so we'll have to fill it in a bit. So the first step is the BGP configuration, which we can copy paste.
Okay.
And this we will have to apply with Calico CTL instead of kubectl, by the way. Okay.
Okay. No, I got it.
Mm-hmm.
There we go. Okay, so we want our server-side array.
Okay, so let's leave that out for now. This will set up later. We can just remove those two fields. We're going to edit this file later and reintroduce them as a party trick, but we won't need them for now. So you can just comment them out. So let's just take in what this all says. So what Calico does by default, if you install it on an IPv4 network, it will create an overlay network, and it will use BGP as well, but in a node-to-node mesh, as we call it. So every node will talk to every node and use BGP to tell each other, I have these pods. So it's like a mesh network. So node A will tell, I have the nginx pods. Node B will tell, I have the Alpine pods. And but we don't want this behavior because we have a router at packet at the top of a rack, and we can just tell the router where the routes are. So we're going to disable the node-to-node mesh by setting node-to-node mesh enabled false. And then we're going to later configure Calico to directly talk to the router. And so this means that all the traffic will be reflected through the router from node to the other node instead of going through an overlay network. And this is also the reason why we don't need to have some kind of overlay network, but we can just use a flat address space because we can bounce off all the routes between the pods through the packet routers. So this is why we have this node-to-node mesh enabled false. It's enabled true by default, so we set it to false. So can we apply this configuration using Calico CTL? And
try. So
wait. Yeah, we have to do two things first. We have to explicitly set the kubeconfig environment variable, because otherwise Calico gets angry. And then we set it to your kubeconfig path.
I think that's already set, because we can do this.
Yes, but
Okay.
and we have to set export data store underscore type equals Kubernetes. This is because Calico can run in two modes. You can either store all the networking information in etcd directly. And this is because you can also use Calico on non-Kubernetes nodes to handle routing. Or you can store it in Kubernetes directly, and we'll use custom resource definitions to store everything.
Cool. Okay.
Yeah. So
now I can
Calico
run
is
Calico.
CTL apply F, and then our file. Yep.
Oh, I'm sure I installed you.
I did so too. I saw you install it. Oh, maybe not on the admin. No, not on the admin node. We installed it on your the other box.
Machine.
Yeah.
Okay, so curl not and
Okay, cool. Okay, so now we're going to set up Calico to talk to the packet router. So if we go back to my file, you will see a BGP peer file, BGP peer snippet. Just copy one of them. Yes. We don't need the template stuff. Just, yep, that's enough. Yep. So I have a little template that generates it for every node in your packet project. So this will be the host name, admin. Then this will be the address of the packet router, which we can look up in. And of course, if we did this all nicely, we would do this with Pulumi and get the attribute out and then link it all in. But this, I'll leave this as some. If you can send a PR to my project to convert it to Pulumi, I'll accept it. So if you go to the admin node,
I will definitely automate all of this. No problem.
yeah. So you should see the gateway. Yeah, exactly.
Here, right?
Yeah. And then this AS number. This is how each router identifies itself in BGP, as I understand it. People now say, you don't know how this works. I don't know how this works. I just tried it out and it worked. So this is the identifying number of the packet router. As long as you didn't select enable passwords when you set up your packet project, this should be enough. Otherwise, we also need to provide the password of the router. But I don't think you did that, right?
No password. We're good to go.
Yep. And the last field is a node selector. So this will, usually when you are on-prem, you will have one router and many nodes will be talking to this router, right? In the packet cloud, each node gets assigned its own distinct public gateway. But usually you will have, 20 nodes talking to the same public gateway. And this way, you can use a node selector syntax here to, for example, say all nodes should talk to this router, or all nodes in Rec 1 should talk to router A, and all nodes in Rec 2 should talk to router B. And this way, you can describe what your topology looks like in your data center. But in the case of packets, every node has its own router, and it talks to it individually. So we'll have to create a BGP peer object per node that we add. So, any questions about this or things that are unclear?
No, I think that makes sense.
Yep.
So we're telling this, You're saying if we add worker 1 and 2, if we decide to go down that road, that we would just duplicate this file, changing the node here, right? The node name.
Yeah, and the peer IP also, because every node will talk to a different gateway address in packet. So if we apply this, okay, can you now type sudo? Oh no, yeah, Calico node status, Calico CTL node status. So now we can see that it has established a connection with the routers at packet, and that this connection is up. And this should mean that Calico is now announcing where all our pods are. So if we now go to if we now curl it should work, I think.
It does.
Woo! And it will even work from my computer. So if we want to do a party trick, you can send me the link to the pod in the chat, and
Yep.
and if I go to it,
You can share your screen too if you wish, if you want to show it off.
yeah. So let's share my screen. Okay, I'm sharing my screen.
Yep, we're now switched over. There we go.
Look at this. There you go. All the way from a pod in your network through the packet routers to my house in Germany, with no overlay networks.
Okay, that's pretty cool.
That's pretty cool, right?
Yeah, I'm impressed.
Okay, so do we want to add another node to our cluster? Because the next cool party trick that we could do, if you want, if you still have time, is we can set up some load balancing and have a service that we can expose to the outside world.
Yeah, I definitely want to see this service stuff. So let's do that then.
Yep. So, but yeah, we can do it with one node, but it's not that interesting. With 2 nodes, I think it's cooler, right? So, if you
we need our kubeadm config, right?
Yeah, but we're gonna write a join configuration instead of an init configuration. But you can find that again in my repository. So
you've done all the hard work, so I don't have to.
Exactly. So you can find this over there. Yeah, perfect.
All right, so I'm going to paste this into code, remove indentation again. Close that. Go back over to my terminal, and we will create a content YAML. We can remove this.
Yeah, and what did you remove just now? Wait, can you think we removed too much? No, yeah, that we can remove. Yes, correct. Good.
That syntax was a bit weird, right?
Yeah, certificate key can go and control plane can go as well. Yep.
We can remove the volume that we don't need, and then we need to add our address, right?
So this is the address. Very good.
Okay, so worker 1, BCP6 address.
But we are on worker 0, right? It's not worker 1, are we?
No, we're on worker 1.
Okay, good.
There is no worker 0 because it wasn't automated. Well, it was automated, but I didn't add an incremental loop counter or anything.
Yeah.
How do I get the join token again?
Yeah, there is some print command for this to get a new one. Yes, I think it's kubeadm token generate. No, this will just generate. I think we need
join. Well,
wait.
There we go.
Yeah, but that just generates a token. It doesn't store it, so that's not enough.
Should I just scroll up and find the first one?
Yeah, and otherwise we need to rerun a certain part of the init phase. Wait. Kubeadm generate new token. I will just ask Google. You found it?
Yeah.
Yep. Yeah. Okay. So we will have to set. So we can do the token and set it. If we are good citizens, we also set the discovery token CA cert hash. But I just have unsafe skip CA verification now. That also works. It's not completely unsafe. So it's only unsafe if somebody knows what your bootstrap token is. So if that leaks, then somebody can impersonate the control plane. But we can just skip it for now. It's not like anybody can see this token right now, right? On the stream. Oh, wait. But that's fine. Yeah.
Okay. Anything else I have to change here?
No, I think that's it. Oh, wait, I see a typo. 1 sec. Open it again. First line, there's a space too much. Yeah, perfect. So now we do kubeadm join -- config.
Yep. I need to install it again, though. Because we've all installed it on other nodes. Really? I should have done the user data in advance, but I will automate this.
Yep. And you'll also have to install Docker, disable swap, and set this forwarding rule.
Got it. So install Docker. Let's put up the echo 1 command.
Exactly.
And I can manually do the other 2 commands. So let that go. We want to do system control Docker. enable Docker.service, swap off. I'm assuming the device will be the same. Oh, it was 2, wasn't it? And echo. Got it.
Yeah.
Means I can do kubeadm join config.yaml.
Mm-hmm.
Oh, copy that before that. Oh no, wait, I did run this, right?
Yeah.
Oh no. Install. I'll just run all again.
Maybe it got confused because of sudo again. Or no?
It will. I'll get you one of the.
Yeah, this is working.
Oh, maybe I didn't run it. Oh no, I installed Docker.
Mm-hmm.
So let's just confirm what I call the local config, config.yaml, kubeadm join, config.
Okay. Unknown field bootstrap token. Interesting. Oh, it needs to be indented once. Yeah, bootstrap token need to indent. And then let's see. I think we made a little typo there. What does it look like? Oh yeah, that's good like this. Yeah.
Okay.
Okay.
So up here, I'm just going to run the nodes. Hey, so worker one.
Yeah, it's not ready currently because it's still starting up the Calico node, probably, the daemon. So it runs this as a daemon set on each node, and it will take a little while to come up.
Okay, we'll just run that with a watch, wait for the status to change.
Yep.
So what we're going to do now is we're going to run multiple nginx pods, expose them with a service IP, and use that to do load balancing. Is that correct?
Yeah, exactly. So let's first delete our nginx pod and create a deployment instead. So we can do kubectl create deployment, and then we do, I don't know, replicas 10 or something.
I'm really looking forward to that new generator RAM that's coming. So deployment, nginx, image, nginx, replicas, right.
Yeah, and now we can do, and hope if we do O wide, we'll see that they get scheduled hopefully across the cluster.
Yep. And we just wait on 2 more.
Yeah, it still needs to download the image on the other node, probably. Or
this is the watch run and then stop the installation. So do we still need to, when we were looking at the Calico, we need to add our BGP peer, is that right?
yeah, exactly. So we'll also have to add the worker one. Yeah. So we can just add another element to the list.
Yeah, I've been paying attention.
And this, of course, again, smells like templating and automation. But,
so I need its IP address, but also the gateway. So that
only the gateway you need.
only the gateway. Okay.
Yeah.
It's 4.
Okay. And we can Calico apply this. Yeah, and now on the worker we can do Calico CTL status, node status. So the thing is, you have to run this on the node itself because it talks to the bird daemon directly that's running. So bird is the daemon that runs inside the Calico node pod that talks to the router.
Okay.
Aha! Look at this. It's not healthy. let's look at the pods in the
Is it
Calico
still be
system.
the images?
I don't know, but something is off.
So we're still waiting on. Oh, so this node I don't think is healthy yet, right?
Yeah. So there are a few. Can you look at the pods in the Calico system namespace? Are they all running? So there's one crashing. You see? It has crashed 5 times in the past 3 minutes, so it's not very healthy.
Yeah, both the worker one pods are failing. So let's grab the logs.
Yeah, let's see what's up. This is where we go off script. Oh, the namespace. Yeah. Okay. What is the error?
It has successfully loaded the config. I don't think it crashed yet.
Can you look at the Calico node one? The Taifa pod is less interesting. I don't even know what it does. I think.
So let's do a right. I mean, that shouldn't be anything there. But. Failing. Part not ready.
Okay. But why not? Oh, look at this. No such file directory node name.
Oh, we didn't modify the resolve.conf.
Yeah, that might be related, but not sure. But
and we also have an error here saying that this node name file does not exist.
Yeah, this is all a bit suspect.
Yeah, that directory is.
Yeah, I'm not sure if this is a directory inside the pod, the thing or not. Okay, No
pressure.
Can we look at the logs one more time? Maybe it tells more now.
I might have to delete it if it's still in pressure back up. And catch it quickly.
I think we're now looking at the wrong one. This is the healthy one, I think. We need to have the one on worker one. Aha, I see what's going on. You see the IP address? Oh, no, wait, that's okay. Never mind. Yeah, there's something fishy here.
Why has it got an IPv4 address?
Exactly. So I think I know what we did wrong.
You say we, but you mean me, right?
Well, no, we together. Can you? Okay. Yep. So this usually means, so we have to in our kubeadm config tell the worker what their IP address is. If you don't do this, it will. But we did this.
No, because I was going to update this, and you told me we didn't have to. So it was your fault. Oh, but it is.
It is. Interesting. Let me think. But yeah, something is going wrong there, and it's auto-detecting the wrong IP address, and this is why it isn't healthy.
Can we do a kubeadm reset on this node?
Yeah,
and just...
we can. But you will have to kubectl delete node it manually from afterwards.
Okay, now shall we? Where's my BGP file? Oh no, we didn't modify anything. Okay. Shall we just try this again then?
Yeah, let's just try it again. I'm a bit confused, but it's okay. Oh, you see? I see the error at the top. There we go. Unknown field kubelet extra args. Uh-huh. It has to be, oh yeah, add 2 spaces in front of kubelet extra args. No, yeah. No. It has to be inside node registration. So, yes, there you go. So it didn't know what its IP was, so it just assumed IPv4, which is the wrong one, right? And then, and this is the part that's not in the documentation, by the way. I had to figure this out the same way as we did now. So, like, nowhere does it say that you need to set this field on the kubelet. It just says. Yeah. Okay, so now it should be in a better state.
Let's just take a look at the system. Yep, there we go.
That looks better, right?
It does. So if I run get pods, I should see all the nginx's now running, and they should all have an IPv6. Cool.
Yep. And we have a service, right? So did we already add the BGP peer for this node? We did, right?
We added a BGP peer for the admin node, yes, but one thing we kept empty was the service sider. I think in here, yeah. So I guess this needs to be enabled.
Yeah, but let's take one step back first, though. Let's just first check everything. Can you do Calico CTL get BGP peer, just to make sure? Yeah, perfect. Yeah, so now comes the cool part of this thing. Indeed, in BGP configuration, which you just opened, we can also announce the service sider. So now we're only announcing routes to our pods to the world, but we can also announce the cluster IPs of our cluster. So we have to set this to the same thing that we put in the kubeadm init configuration. So we'll see service subnet. Yes, exactly. Yeah, and service external IPs we can leave. So you can, this is useful, you can also manually assign external IPs to services if you want to. And then they have to be out of this range, and then Calico will also announce them. But we don't need that for now. So if we Calico CTL apply this, okay, if you go to your packet console now, and you go to network BGP, and then update status, and then refresh the page. Here we can see all the routes that the nodes are telling to the packet router. So if we click on worker 1, for example, or admin, you will see it is announcing the service sider and the pod sider. The cool thing is that both worker 1 and admin will announce the same service block, and this will cause the packet routers to automatically load balance between the two nodes. So you get a load balancer for free, basically. So when the outside world says, I want to reach a Kubernetes service, then the packet router sees there's 2 entries for it. It's either master or worker 1. And they will go to the kube proxy of either of those, and then it will go to the correct pod. Yeah. And you also see that the pod cider is different for each of the. So the service cider is the same because we want to be able to load balance this. But the pod cider is different. So you will have a subnet for all the pods on the master node, and you'll have a pod cider for all the pods on the worker node, and they will be disjoint. So this way, when you try to reach a pod, you see that they're different. This way, the outside internet knows how to route to the correct node to reach the correct pod. Yeah. So we can try this service now that we created.
We don't have one. So
oh, yeah. So we can do kubectl expose.
Oh, yeah, I guess we could do that.
And then nginx. Oh, dash port 80. And then I will just. Oh, yeah, expose deployment. Yeah. Okay. Okay, and now if we go and curl this address, we should get load balanced access to our nginx service. We could verify that by looking at the pod logs, for example. But yeah,
we can. So image functions node info.
Ooh, what's this?
It's from the OpenFAS project, and it's a function that returns information about the pod that is running over HTTP.
Ah, cool.
So the port number might change, but I can fix that. It looks like that's running. Let's just run edit service, X. And I can never remember which way these are. So 8080 is the target port. There we go. We have load balance. The host name changed.
Cool, right?
That is cool.
Yeah.
I like it.
Yeah. Yeah, but there's there's one more thing that we can tweak. So as you see in the routing table that we are announcing to Packet, we're announcing the entire service range. Right?
The whole 108, right?
Yeah. And that's okay. But sometimes there might be pods that are not running on worker 0, but are running on worker 1. But in this case, it will even contact worker 0, even though it's not running any pods. And it will then use kubeproxy to make this extra hop. So this can be a bit detrimental for performance sometimes. So because it will need an extra network hop to reach the pod sometimes. What it does do, it gives you very equal load balancing, which is very nice. But we can also configure Calico to only advertise nodes that actually is running a pod from that service. We can demonstrate this by maybe making sure that there are only pods running on one of the two nodes. And then we can show the difference in what happens with the routing tables. So.
Okay, so we want to edit node admin. Let's add. We can just
taint it again, right? Or some.
Yeah, what's the easiest way to do this without copying and pasting YAML? Edit deployment. Nginx. Let's do RTFM. Opposite of that. Yeah, come on, just give me the YAML.
Oh yeah, this required during scheduling, ignored during. I always get very confused by this stuff.
So let's grab this and add this to our deployment. So where's our spec? My paste is going to be weird with it. So I want to add and then 2. Pop it into an actual YAML file. We want that. And we're going to go, yeah, we could just do host name, right? And we'll just say we don't want schedule on admin.
What is this key in this case?
Yeah, so we're good. We need a label.
We could also, so at the beginning we tainted we removed a taint from the control plane, right? Maybe we can add that again so that it doesn't run any workload stuff. Yeah, we don't have a kube config on the worker, so that won't work. Alas.
Let's just put out of this. Describe. So I could add the master tape again. I guess that might be quicker. Kubernetes master.
Yeah, there's no schedule thing, right? Can add.
I scrolled past it.
Yeah.
Well, the toleration goes on the, well, yeah, there we go.
Yeah.
I'm looking at this YAML going, but that goes on the pod. It doesn't. Of course, I do that. So, admin. And get pods.
What is key 1 value 1? Is that, do we need that? I think it is confusing us again.
Oh yeah, that's not going to be the default. So
Yeah.
if we take a look at anything running on, let's get something from our kube system namespace that's running on our admin node, which will already have a toleration, and then I'll copy the labels. So admin Calico. Let's take a look at you. CD admin. Kube system, edit pod.
Yeah.
Static manifest. And then we set short call. How am I feeling? So much
I have a quicker idea. How about we scale the deployments to 1 pod, and then it's only on 1 node.
Right. Yeah. That would be,
This is me getting creative. Okay, good.
the one I kept is on the admin. So let's see. Oh, I guess that's fine, right?
What is fine?
Because it's running on the admin node, but we're going to change it so the service published doesn't publish the other node, right?
Exactly. So this is great for demo purposes. But okay, if you now look at the routing table, it will still. On packet, just on the interface. So we still see that both nodes are advertising the service setter. But we can configure Calico to only announce the nodes that actually run the pods. So we can do this by editing the nginx service. And we can set this by setting the external traffic policy to local. But there is a catch to this. This only works on node port, type node port. And this is just a Kubernetes API quirk. We're not going to use the node port, but we need it anyway. So, and then we can set external traffic policy to local. We have type cluster IP below still. We have to remove that. Yeah. Okay, and if we apply this, so this should still work. We can ignore the node port. It's only there so that we have access to this traffic policy thing, and it's maybe something that should be fixed in the Kubernetes API. So Kubernetes doesn't really, so cluster IPs being exposed externally is not something that was being thought of originally, I think. They always thought we'll use external load balancer objects for this, so you can do type load balancer and you'll get something from your cloud provider. So here there's a little bit of an API mismatch. But now if we go to Packet and we refresh on the BGP page the routes, so we press update now.
Is this update now something that can be done programmatically?
I don't think so. So, and because they also ask us nicely to only do it every 5 minutes. So the routes are being updated. This is just about the interface getting the information from the router and displaying it to you. So you don't need to press this button to update the routes. It's just to get the information into the interface. That's it. So now we should see that let's see if this now works. If you go to the node that is running the pod.
Yep.
Oh yeah, exactly. We see that it now announces a /128. So it says this specific service IP is exactly on this node. So this is, and if you go to the other one, it should not be there.
Okay.
See? So this now will cause it only to get routed to that node and it will never go to the other node.
But that just reduces that extra hop then, where it doesn't have to go through IPVS or the kube proxy or anything like that.
Exactly. Yeah. So it just avoids this, actually does load balancing itself as well, right? So if your pod workloads are not evenly distributed over your cluster, like we have now, all the nginx pods are on the admin node, right? So it's receiving all the traffic right now. That could also be the case. So if your pods are not spread evenly, and this is also not something that Kubernetes gives you, right? It doesn't give you even spreads. It does a best effort thing, but it might come into cases where resources aren't spread around evenly. Then removing this extra hop through kube proxy can give you uneven load balancing. But it does avoid this extra hop, which is nice. And
is there any penalties, whether it be performance or from packet side, of how many routes can be published in that way? Like if I have a relatively large cluster and I need to with thousands of services and they're publishing thousands of routes, is that a challenge?
Yes. So I don't know what the limits are. There will probably be a limit, and so Calico has some pages about designing your BGP infrastructure, and usually what you'll have routers that announce to routers that announce to routers. You kind of have a trickle-down system to reduce the routing tables, because usually you do not announce 10,000 routes or to one router. It will get a bit confused and it might drop routes or whatever. So I don't know what the limits are, to be honest. This is something I haven't found in the documentation either. But if you do bare metal yourself, then Calico has a very nice tutorial explaining how you should set up your infrastructure and your racks, and how there are some different trade-offs that you can make in terms of network design. But that's dark magic I do not yet understand. But yeah.
So is our usage of Calico here today because they're the only CNI that offers this, or the one that you're just more familiar with? Like, do other CNI implementations offer the same functionality?
I don't know. So I think Calico is the only one that like allows you to do this. So what we call this is like a pure layer 3 network, classic one where we use BGP for announcing routes, and also if you log into one of the boxes and you type in IP route, you actually see all the routes listed, and it's very easily debuggable using. So if you do IP-6, you have to add a -6, otherwise it gets angry. Like you'll actually see like this pod IP goes to this interface, and all the other stuff has to go through the gateway via default route. So it's a very classic way of setting up networks, which also gives you like very familiar tools to debug it for like. And as soon as you have overlay networks and stuff and a lot of IP tables rules, I think these things get less transparent. And so, yeah, I think Calico is the only one. No, wait, there's another one. kuberouter also does this. So there's also kuberouter, which also does BGP routing. And I think you can also combine that with Cilium together. But I haven't tried those two out. But I think in terms of having this BGP by default approach, I think Calico is probably the most mature option out there. Like this is the thing that they advertise with. Like this is what we do. We do flat networking. But I know that, for example, Cilium has some other cool tricks. Like they have this eBPF data plane that you can add, which avoids having to install kubeproxy. And I think Calico is also working on something similar on an eBPF data plane, but I checked and it doesn't work with IPv6 yet. So I couldn't try it out yet.
Wait, I have a nice session planned for next week with someone from the Cilium team. So I'm looking forward to learning Cilium too.
Yeah, cool.
There is a question, if you're feeling brave. So Siam has asked, when do you recommend to use reflectors?
So this is also about like scaling, right? So I must say I don't know a lot about BGP. This is me learning in the past few weeks and trying things out. When do you recommend it? From what I understood from the Calico docs, it's when you want to, like, usually Calico sets up a node-to-node mesh and all the nodes talk to each other. And that will not scale infinitely, right? And instead you can determine some certain nodes in your cluster as you act as the router. I will reflect all the routes through you so that you don't have this n times n BGP connections to announce all the routes. So I think it's a matter of if your cluster is starting to scale to thousands of nodes, you will have to add these reflectors. But yeah, I haven't had a cluster with thousands of nodes yet, so I don't know. But there is a page on the Calico documentation called Calico over IP fabrics, and it explains all the different trade-offs you can make in setting up your Calico network. Like whether you want a node-to-node mesh, whether you want route reflectors, whether you want this trickle-down routing. But yeah. So yeah, I actually think the only use case is to just scale this node-to-node mesh. But in our case, we're not using the node-to-node mesh at all. We're using the packet routers as route reflectors, basically. So, yeah.
All right. Well, my brain is now officially fried.
Yeah.
And there is a lot I think I need to learn and play with in this space. And that was a fantastic, just walking through this step by step and actually seeing how to disable IPv4 and turn on IPv6 and configure the peers. It's all very valuable and very useful. So thank you for taking the time to join me today and go over all of that. I will publish the Pulumi automation in the next couple of days. Is there anything you would like to finish up with before we finish off for the day and I let you get back to your lunch or work or whatever?
Well, one thing we didn't cover at all is, of course, security. So this might be a fun, right? You everything is public now, and that's probably not what you want. Like, I don't want all my cluster IPs to be publicly reachable and stuff. And yeah, that's something we haven't configured yet, but this is something you can do. So Calico has support for network policies. which you can describe which pods can talk to which pods and stuff. And this is something you should definitely set up after you set up an IPv6 cluster, because everything is publicly routable, right? And this might not be what you want, and you want to close the fortress a little bit. Yeah, yeah.
Yeah,
But that's an exercise for the reader.
Yeah, either that or another 2-hour stream eventually in a few
Yeah.
weeks or something.
Yeah.
But we'll see. Yeah, so the policy stuff, the security stuff, I can imagine right now everything is public, so I'm looking forward to shutting this cluster down before it gets too late. But
Yeah.
You also said at the start that you work for Wire, and I believe you may be hiring just now.
Yeah, so we are hiring for a operations position. Experience with Kubernetes would be very helpful, but not needed per se, because so Wire is end-to-end encrypted chat platform, collaboration platform, like Slack competitor. And we also run Wire instances on-premise at customers. And we are migrating our old cloud infrastructure to our new cloud infrastructure, which is Kubernetes-based. And so we need people who have knowledge about on-premise hosting and all the dirty nitty-gritties of other people's shitty networks. And we need people to help us migrate to our new cloud infrastructure. So we're looking for people for that. So yeah, feel free to check out jobs.wire.com. And then
Thank you very much.
Job ad there. Yeah, cool.
All right. Well, honestly, that was really insightful. I learned a lot. So thank you very much for taking the time out to join me again. And I'll speak to you all soon.
Yeah, see you around.
Bye.
Ciao.